This is my second video regarding relative velocity. For this video, I have selected a past paper question given in GCE A-level. So this is 2009 Combined Mathematics 2, question number 1, part B question. It states, a submarine which travels at a speed u kilometers per hour sights a ship at a distance d kilometers in a direction 30 degrees west of south in the sea. The ship is traveling due north with a velocity of v kilometers per hour where u less than v less than 2u. Now there are 3 items in this question. Let me take submarine as A, ship as B, and C as S. Submarine which travels at a speed u kilometers per hour. So the velocity of submarine, that means velocity of A, it is moving in C. With respect to C is u. The direction is not given, that means it can move in any direction. Then ship is traveling due north with a velocity v. Therefore velocity of ship, that is velocity of B with respect to C, relative to C, is north, magnitude is v. Then they have given the initial location of these 2 items. Submarine sights a ship at a distance d kilometers in a direction 30 degrees west of south. So initially submarine is somewhere here. So this is A, this is south. It is 30 degrees west of south along this path. So this can be 30 degrees. It is west from south. So let me take this point as the location of ship B. So ship is traveling to north with a velocity v. So the distance between A and B is d kilometers. By considering the motion of the submarine relative to the ship, show that in order to intercept the ship, so submarine is going to intercept with the ship. The submarine may proceed in one of the 2 directions and find the angle between these 2 directions. Now we have to use circle method to draw the velocity triangle, because one direction is unknown. Direction of submarine with respect to C is unknown. So this is the velocity equation. Velocity of, we have to consider motion of submarine relative to ship. Velocity of submarine relative to ship, it is B, is equivalent to velocity of A respect to S plus velocity of S respect to B. Velocity of A respect to S is in any direction, magnitude u. S respect to B is downwards, magnitude v. This is velocity of B respect to ship, B respect to C. So this is velocity of C respect to B. So we have to change the direction. Here I have taken PR to represent the first vector and RQ to represent the second vector. Then PQ becomes my resultant. Now in circle method, I taught you during my first video, we have to interchange these 2 vectors in order to take this velocity, where we know both direction and magnitude, as the first vector. So V downwards will be represented by PR first vector. Let me draw that first vector. It is vertically downwards. Magnitude is V. Since I can't draw the second vector because direction is unknown, I have to draw a circle. The center of my circle is the end point of this second vector. But before that, I have to consider the radius of this circle. This is the center. Radius is equivalent to the magnitude of my second vector. Second vector is u. From this inequality, we can compare the magnitudes of u and v. They have given u is less than v. That means the second vector which I am going to draw now is shorter in length than the first vector which I have already drawn. So that is taken from the inequality given in the problem. So I have to complete a circle which is smaller in radius to this first vector. So the circle should be something like this. Then this is the starting point of my first vector. I have to complete the resultant. The direction of the resultant is along this path because the submarine is going to intercept with the ship. If submarine is going to intercept, A must travel along this path. Here I am going to consider velocity of A, velocity of submarine with respect to ship. Now ship is stationary at this location. If A is going to intercept, it must travel along this path. That is the logic. In the question, they are saying us to show that there are two directions. So I have to complete my resultant such a way I can complete two velocity triangles. Then only I can say that there are two directions for the submarine to proceed. So the circumference of the circle is intersected by this AB line or the resultant vector at these two locations. So this is my first vector, which is PR. R is the center. So the resultant PQ, so this is Q1, Q2, since we have two directions to show. So this becomes P, Q1, Q2. This is R, Q1, Q2. Now I can complete two velocity triangles like this. So this is the second vector which is equivalent to U. This is the second vector equivalent to U. These two lines are radius of the circle. So I can label these angles. They are equal. They are alpha. This angle is 30 degrees because I have drawn the path AB, that is 30 degrees inclined to south, 30 degrees inclined to my vertical. Now from this diagram I can say the submarine can proceed either in RQ1 direction or RQ2 direction in order to intercept the ship. A can travel along RQ1 or RQ2 to intercept B. Now I want to find the angle between these two directions. So angle between these two vectors is the angle here. These two angles are alpha, sum is 2 alpha. So the third angle of the triangle is 180 minus 2 alpha. That is the angle. So alpha is an angle used by myself. So I have to find the magnitude of alpha first. For that, I can resolve this vector in this direction. If I complete a right angle triangle like this, so it is an imaginary triangle. PR vector resolved to this direction, that is equivalent to PR sin 30, because it is resolved away from this 30 angle, it is sin. That is equivalent to, I can resolve this line in this manner. According to this right angle triangle, I can resolve RQ1 vector to this direction, that is RQ1 sin alpha. So PR is V, so that is V sin 30, sin 30 is half, RQ1 is U, U sin alpha. So sin alpha becomes V divided by 2U. So alpha is sin inverse V over 2U. So the angle between the two directions are phi minus 2 alpha, that is phi minus 2 times sin inverse V over 2U. Now I can complete a right angle triangle to represent my angle alpha. So sin alpha, we found that as V over 2U, that is opposite side V, hypotenuse is 2U. Then adjacent side, from Pythagoras relation, I can take that as 4U square minus V square square root. So this can be useful to show the expression given in the next part. So next part, they want us to show this expression for the time difference. So time difference of the two paths. So if submarine is traveling along RQ1, it can be a different time. RQ2 another different time. First I have to find the velocity of the submarine with respect to ship. That is, I have to find the magnitude of RQ1 vector. So before considering these times, I have to find these two vectors. What are they? PQ1 vector and PQ2 vector before this. For that, I can do this kind of a construction. I am going to draw a perpendicular from this center to the base PQ2. So this is equivalent to U cos alpha. I have resolved this vector downwards, that is U towards the angle cos alpha. This is also U cos alpha. Resolve U downwards towards the angle U cos alpha. Then PQ1 vector is this entire length. See carefully, this entire length is V, this vector is V. V resolved downwards. What is that? V cos 30. So V cos 30 is, we write it as cos 30. V cos 30 is this total length. then I have to remove this part, u cos alpha. So PQ1 is v cos 30 minus u cos alpha. Then PQ2, this entire length is sum of this v cos 30 part plus u cos alpha. So that is v cos 30 plus u cos alpha. So it is like factors of difference of two squares. This is v cos 30 minus u cos alpha. This is v cos 30 plus u cos alpha. Now we know that time is equivalent to distance divided by speed. So let we take t1 as the time taken by the submarine to travel in its first direction, which is PQ1. The speed is PQ1. So distance the submarine going to travel in order to intercept the ship is d, because initially the question gave the separation as d. So it is d divided by PQ1 vector. Then T2 is distance, same distance, divided by second vector PQ2. Now we have to show the time difference, that is T2 minus T1, or else I can take T1 minus T2. It will be d over PQ1 vector. Since I have taken T2, it should be PQ2 vector minus d over PQ1 vector. So that is, when I take d out, it is 1 over PQ2 minus 1 over PQ1. Now I can take the common denominator, PQ1 into PQ2. This is PQ1 minus PQ2. So what is PQ1 minus PQ2? This vector minus this vector. V cos 30 get cancelled when I take the difference. Then minus u cos alpha minus u cos alpha, it becomes minus 2u cos alpha. That is the difference between these two. Denominator we have the product of these two. Earlier I told these two are the factors of difference of two squares, a minus b, a plus b. So I can write here a square minus b square. What is that? Square of this vector, which is v square cos squared 30 minus second expression u square cos square alpha. So this is a time, even though it is a difference, still it is a time, so this cannot be negative. So time, or T2 minus T1, should be positive. It should be greater than 0. Therefore I can change that minus to plus. So it should be modulus. To make it plus, it is 2ud cos alpha over v square cos 30 is root 3 over 2. When I take the square, it becomes 3 over 4 minus u square cos square alpha. Now we can substitute cos alpha to this expression and get this answer. So sin alpha is v over 2u. From this triangle, right angle triangle which I have constructed, I found the adjacent side as 4u square minus v square. Therefore cos alpha should be adjacent side over hypotenuse. So here we have time difference as 2ud cos alpha. What is cos alpha? This expression over here, over 2u divided by denominator, that is 3v square over 4 minus u square cos squared alpha. That means the square of this expression over 4u square. When I take the square, then u square get cancelled. Now take the common denominator for the denominator of our question. So here also I can cancel 2u with 2u. It is d square root 4u square minus v square for the numerator divided by, then take the common denominator here. Common denominator is 4, that is 3v square minus 4u square minus into minus plus v square. Now here we have 3v square plus v square. It is 4v square minus 4u square divided by 4. We can cancel these 4's and we have the time difference as d into 4u square minus v square divided by v square minus u square. So this is the expression they have given us to show. So this is a long simplification, but the logic is simple. I hope you have understood everything which I have discussed here. So I discussed how to solve 2009 relative velocity problem. Thank you.